Hi, today we're going to discuss about parabolic reflector as a car headlight. Actually, as a consumer, we always want the car that can make other people amazed with us, especially for the design and also the speed of the car itself. But for the manufacturer side, they actually always want the most effectiveness and the less costly for the car manufacturing. So today, we're only going to focus on the manufacturing of the car headlight. So, what is the best shape for the car headlight? And then the second one, where should we put our light in the parabolic reflector itself? This is the important because as we know, as we change the length or the width of the car, it's gonna affect how far the light gonna reflect.
So, there are three essential kinds of reflecting surface: flat, spherical, and parabolic. Now, we want to go through one by one type of the reflector surfaces. First, we have a flat reflector, where the light are come in a numerous way, and just a little light reflect towards a path. Next, we're gonna see the spherical reflector. They return the light beam to the focal point. But the spherical reflector will not move the path that the reflector confront. Now we can see on the parabolic reflector, they assemble the light from the focal point of the reflector and return it in a move parallel toward the path reflector is confronting. So, from all the detail that we have, you think which is the best shape for the car headlight? As we can see, the best shape for the car headlight is a parabolic, with all the statement have been stated before.
There are three positions of light. The first one is at focal point. The second one is behind focal point. The third one is front focal point. At focal point, produce a parallel beam. Behind focal point, produce a divergent beam. Front focal point, produce a convergent beam.
So, based on the length given by the car manufacturer, the engineer have come out with two equations for the parabola. The equation are, firstly, we get 12x equal to y square minus 10y plus 97. The second equation, we get 20x equal to y square minus 10y plus 145. Okay. So the first step to sketch the parabola is put in the standard form of the parabola. What is the standard form? The standard form is the first formula that mentioned earlier. From previous formula, notice that hk are the vertex of the parabola, but the equation above does not show the value. To make it clear, it is important to put in the standard form first. In this calculation, the directrix omitted due to it does not give any function to car headlight production. These are how we calculate and put the equation in the standard form. First, we put the function with square to the left, so we rearrange the equation. Secondly, complete the equation with use completing the square, so we can get the value. Third step is factorize the right side function, so thereby the clear view of parabolic equation used to find the vertex for both of the function are in the same vertex, which is sig phi. In the real life case, this vertex actually just for the sign that both are in the same vertex, so the different what can be seen. Usually the vertex are in origin, but as we say, it's just to show they are in the same vertex and see they are different what. For P known as C in the graph 2, thus we need to use the C value to know the direction graph will open. Now the C value is positive. This means that it will open on the right direction. Next, the focus of the equation are determined by P. So the calculation are, first we get 4P1 equal 12. Second, we get 4P2 equal 20. So we rearrange, so we get P1 equal to 3 and P2 equal to 5. The focus are found for the equation 1 by moving 3 in the direction of the parabola. Then for the other equation by moving 5 away from the vertex direction parabola opens. So after we move the parabola with the right number, so we can get vertex 6 5. So second vertex we get 6 5 2. Focus we get 9 5, and second focus we get 11 5, resulting in the coordinate given by 9 5. Moving to equation 2, the coordinate of focus are 11 5. As said before, this will be the location for the lamp which can spread the light. Flashlight is located at the focus, and light from that point is reflected outward parallel to the axis of symmetry. Okay.
After that, we move to the endpoint of the latest rectum, which is the width of our car headlight. For the first equation, we get the latest rectum is 6 and the second equation is 10. LR2 is bigger than LR1. This shows that the width for the equation number 2 is bigger than equation number 1. From this, we can get endpoint by moving 6 up and 6 down. For the first equation, we can get endpoint is 9, 11 and 9, negative 1. For the second equation, we can get it by moving 10 unit up and 10 unit down. We can get the endpoint is 11, 15 and 11, negative 5. As a summary for a parabolic reflector as a car headlight, we can see that for both equations, there is no a big difference. But then, as a manufacturer, we always want to minimize our costs. Hence, manufacturer will choose the first equation, which is y minus 5 square equals to 12 in bracket x minus 6. Why we choose this? Because the faster the lamp reflects from the parabolic mirror, the bright and the sharp the light will be.
Elliptical satellite and planet orbits. So now let's talk about the second application, which is planet move in elliptical orbit. Firstly, the problem that needs to be solved is why the orbit is an elliptical, not a perfect circle. Elliptical orbits are much more general and allow for a wider range of initial conditions which existed when a planet system forms, thus making them a more probable solution for the properties of a planet's orbital characteristic. The elliptical orbit option is what all the planets in our solar system follow, and it makes sense why this type is far more common than a perfect circle. When an object is too small or too slow or to escape the gravitational pull of the sun, it falls into a repetitive elliptical orbit that is largely dependent on its original energy and trajectory when it entered the system. The orbit can also be affected by gravitational effects of other orbiting planetary objects as well, making it imperfect, eccentric, and highly dependent on other factors.
For ellipse equation, example 1, the Mars orbit the Sun on an elliptical path whose minimum distance from the Sun is 129.5 million miles and its maximum distance from the Sun is 154.5 million miles. The Sun represents as one of the two foci of the ellipse. So now, let's find the standard equation for the elliptical orbit of Mars around the Sun, where the center if the ellipse is at the origin. For the first step, we add the distance, 129.5 plus 154.4, and we get 283.9 million miles. Since we get the total distance, we can find the A. To find the A, we need to divide 283.9 with 2, and we can get 141.95. When we get our A, we can find the distance from the center to the sign. We minus 141.95 with 129.5 and we get 12.45 million miles. Now we get all the information. The total distance is 283.9 million miles. The A is 141.95 million miles and C is 12.45 million miles.
So how to find the B is we use equation b square equal to a square minus c square. So to find b square, we just plug in a value of a square and c square. So value of a is we get 141.95 squared minus by 12.45 squared. So we get b value is 141.4. After we get the b value, so we can complete the equation for the elliptical orbit of Mars around the sun, since we already have the a and b value. So we just sub to the equation is x square over a square plus y square over b square equal to 1. Plug in the a and b value into the equation. So the elliptical orbit of Mars around the sun equation is x square over 141.95 squared plus y squared over 141.2 squared equal to 1. So that's the elliptical orbit of Mars around the sun equation.
So as we know, an ellipse is the set of all points for which the sum of the distances from the two fixed points which the two foci is constant. In the case of an ellipse, there are two foci and two directories. Overall, it may be said that there's a lot of things or objects require ellipse application for a specific purpose. Thank you. That's all from us.